Welcome to Unit 3. In this unit, we'll talk about bonds, interest rate, and rate of return. We'll cover this topic for the next couple lectures. So the first question you want to ask about this lecture is, what is interest rate, and why do we care about interest rates? As I mentioned in the first video, bond is kind of a debt instrument. So when you're buying a bond, you're actually lending money to a company or a government in return of getting fixed payments in the future. You would get paid interest rate while you're borrowing, when you're lending the money to a company or a government. So if you think of the borrowing side, then it would be actually cost of borrowing the money from you. Then why does interest rate get paid from borrower to lenders? So one reason is because lender has an opportunity cost, or you can say the time value of money. So when you lend money to someone else, you can't use that money for the time being. So the borrower is kind of compensating for the value of money that is lost over that period. The second reason of paying interest rate is because of inflation risk. So if I'm a lender, I would ask the borrower to compensate me for the inflation risk by paying me interest, because by the time the borrower pays me back the money in the future, it would not be the same value as it was before. So this also means if the expected inflation rate is higher, then it means the interest rate will be higher too. The last reason is because of default risk. As a lender, I would have the risk that the borrower might default and not pay me back in the future. This means the borrower has a higher likelihood to, if the borrower has a higher likelihood to default, then the interest rate would be higher as well. So, debt securities being a promise of future payment, how can you compare which bond is more valuable than the other? Well, interest rate is kind of the key of valuing these different promises. So the simplest concept when we talk about interest rate is the present value and future cash flow. Those of you who have finance background might know this formula where PV equals CF over 1 plus I to the power of n. So let's look into this formula and let's see what it means. So PV means the present value. CF is the future cash flow, which is the amount that someone promises you to pay back in the future. So the present value of this promise is equal to CF divided by 1 plus I to the nth. So I is the interest rate and n is the number of years. So for example, let's say present value of $100 to be received 1 year from now at 10% interest rate is going to be $100 over 1 plus 0.1, which is going to be the interest rate, and since it's 1 year and it's going to be 1, equals to $90.9. So what you can notice here is if you have higher interest rate to discount the future value, it means that you're going to have smaller present value payments. Then why is that true, and why is it like that? So there's two ways to look at it. So one way you can see it is right in the formula actually. Algebraically, it makes sense because I here is in the denominator. So if I increases, in the denominator, it means that the present value is going to decrease. Okay, so So logically, how would you think? What does it mean to have high interest rate? So it means that you would have a higher opportunity cost and you would less value future cash flow. So the now is more important than later. So vice versa, with lower interest rate, the present value would be bigger and the future value matters as much as the present value. So let's say I is equal to 0, which is a very extreme example. So let's say I here is 0%. That means PV is equal to CF. So you would be indifferent from having $100 now and $100 in the future. You would be indifferent because there is going to be no growth from current to future. Oops, sorry. So let's go over an example here. Suppose you're planning to take a vacation in 2 years. How much would you need to save now in order to have $2,000 in 2 years at an interest rate of 4%? So the question is asking, what is the present value of having $2,000 in 2 years with 4% interest rate? So you can say that I is equal to 4 or 4% or 0.04, and then the n here is going to be 2. And then CF is the amount that you're getting in the future, so the cash flow in the future is going to be 2,000. Then what is your PV? So the way you want to solve this is going to be PV is going to be equal to 2,000 over 1 plus 0.04 to the power of 2, so squared, basically. So in this case, when you calculate it, this will equal to, I think, $1,849.1. So this would be the amount that you would save now to $2,000 vacation money. So this was a simple example of a formula. So then how are you going to use it when it comes to debt instruments and bonds? Come on, okay. So the question here is, how do we price different debt securities? So remember that bonds are a promise of future payments, and future payments would be fixed. So you want to know how much the bond would cost you in present terms and how much you should be willing to pay for it. So there are different kind of bonds like coupon bonds and zero coupon bonds. So because there are different bonds, there are different ways to calculate it, but all of them have three things in common. So 1, they have fixed payments until expiration. Also, they have expiration date. It's also called maturity date, or just maturity. And even though bonds give you fixed payment at maturity, the price you're paying will be different every day. So the price is variable. It's a variable price depending on the market situation, etc. So now let's talk about the simplest form of bond called discount bond, also known as zero coupon bonds as well. So the reason why it's called discount bond is because it's sold at discount, which means it's sold below face value. I'll explain that later too. So it means there's going to be no coupons. So at maturity, you're going to be paid face value. Example of these discount bonds are treasury bills issued by the government. On the private side, there's going to be commercial papers issued by big corporations. So let's go look at a numerical example here. So let's say that there's a discount bond. The face value is $1,000. It's a 1-year T-bill selling for $950. So differently said that you're going to get paid $1,000 after a year it matures, but currently you're buying at $950. So you can see that this is going to change. So this is the price you're paying for the bond, but this is going to be a fixed value. So let's take a look how a bond looks like to get a better idea. This is an old picture of a discount bond. Nowadays they don't issue this kind of paper bonds, but instead bonds are in electronic form. So the key element you want to see here is first, here, the issuer, which in this case is the United States of America. The second element is the maturity date. So I don't know if you can see, the maturity date is April 9th, 1970. The issuing date was October 9th, 1969, which is about 6 months. So it's the maturity date is here, and this bond is called 6-month discount bond because the duration is 6 months. The third thing you have to take a look is the face value paid at maturity. So you can see you're getting paid $100,000 at this maturity date, April 9th, 1970. So everyone who owned this bond would get paid $100,000, but also note that the price is not printed anywhere on this T-bill, which means everyone gets paid $100,000, but the price that they paid for this T-bill is going to be different because it varies. So now let's talk about coupon bonds. Coupon bonds are a little bit different but similar with discount bonds. So the similarity is you have face value, same as discount bonds, but you would have coupons, which is annual payments. Sometimes it could be semi-annual. You can get paid twice a year. The coupon can be paid in dollar amounts, but it can be also paid in rates. So when you're talking about coupon rate, it's actually like a percentage of the face value. So for example, let's say the coupon rate is 3%, then it means the bond owner would get paid 3% of the face value of the bond every year until maturity. So generally, coupon bonds have a long-term maturity and makes them to have coupons in the first place because, let's say it's a 10-year maturity coupon, then it means that you have to wait 10 years to get paid one payment of face value. But you don't want to do that. So you want to get paid over 10 years, the coupons in between, and then you also get paid face value in the end. So the example of coupon bonds are treasury bonds that are longer than 10 years, and then treasury notes, which is a bond that has a maturity of 1 to 10 years. And then there is also corporate bonds. So let's take a look at another numerical example here. So let's say there is a coupon bond with $1,000 face value. The maturity is 2 years, and the coupon rate is 5%. And the bond is selling for $1,020. So this means you're paying $1,020 right now for the bond. It means if the payment is annual, then it means that you're going to get paid twice each year. The amount that you're going to get paid is going to be 1,000 multiplied by 5%, which is going to be $50 a year. Because $50 is, so it's going to be a 5% fraction of the face value. And after 2 years, after you have no coupons left, after it's matured, you're going to get paid $1,000 face value. So let's take a look at what a coupon bond looks like. As I said before, these are very old versions of the coupon bond. Now they don't do it like this anymore. So let's look at it. So number 1, here's your issuer. Similar with the discount bond. The issuer here is the United States of America, the government. And then, let's see. I don't know, it's kind of blurry here, but the maturity date is here, which is 8 years. So this is an 8-year bond. And then here is the face value, which is $1,000. So it means that you get paid $1,000 at maturity. And number 4, you have 9%, which is the coupon rate. So as I mentioned before, the amount that you're going to get paid is going to be $90 because, not 90%. It's going to be $90, which is going to be 9% of the face value here. So down here, you can actually see where it's circled right here. You can actually see the actual coupon attached, which is paying $45 because this coupon was a semi-annual coupon, so it was actually paid twice a year. So it pays $90 in total of the year, $45 at each payment of the year, so it's paid twice a year. So one thing to I have to mention is there's only 4 coupons, but there should be 18 coupons. Maybe someone used it, so there should be 18 coupons attached here, but there's only 4. And the same as discount bonds, the price is not printed anywhere because it varies. So let's come back to the question. How do we price different bonds? So let's look at the price of the coupon bond in particular. The price of a coupon bond is a sum of present value of all the future payments. So simply put, the bond is going to be some present value of all the payments you would get in the future. I know it's difficult to understand, so let's look at an example right here. So let's say there is a 3-year bond with the face value of $1,000, and the coupon rate is 10%, and the interest rate is 2%. To solve this, let's think of all the payments you can get. So you would first get coupon payments over the years, and in the end, you would get the face value payment after it matures. So here's the formula. You can see this is the amount of coupon payment you would get. In the first year, it's going to get discounted. This is the second year, which is going to get discounted, but you're still going to get the same amount of coupon payment. This is the third year of coupon payment, discounted. And after it matures, you're going to get paid face value, which is going to get discounted with the with interest rate over 3 years. So this is going to be like the present value of the first year coupon payment. This is going to be the present value of the second year coupon payment. This is going to be the third year payment, like coupon present value of coupon payment. And then this is going to be the third year payment present value of the third year payment that you get from the face value payment. So summing that up, it would be $1,230.7. So now let's look at how to get the price of a discount bond. This would be much easier because there is going to be no additional payment occurring. So for example, to get a price of a 1-year bond that has $100 face value and with a 5% interest rate, it is going to be simply the simply formula of the present value and the future value. So it's going to be 100, the face value, over 1 plus 0.05. This is going to be the interest rate, and the number of year is going to be 1. So, and it's going to be, the price of this bond is going to be 95.24. So this is how much you should pay for the bond, how much you should be willing to pay for the bond. So you can see why this is called discount bond, because the price you're paying, the price it's sold is less. It's going to be less than the face value here. Let's look at a couple more examples. So in this case, we have a bond that has a face value of $100, and it's a 1-year discount bond with a yield of 6%, which is also means interest rate of 6%. How would you solve this? So this is going to be your CF, and then this is going to be your I, and then since it's a 1 year, your N is going to be 1. So the current price, the current value of it is going to be $100 over 1 plus 0.06 to the power of 1. So this is going to be $94.31. So as you can see, because it's a discount bond, the price is going to be less than the face value. So let's work on an example with a coupon bond. So what is going to be the price of a $100 face value, it has a 2-year maturity, and then the coupon rate is 4%, and the interest rate, the yield, is going to be 10%. So because it's 2 years, we want to think about the first payment of the first year and the second payment of the second year and the final payment of the face value. So let's calculate the amount of money you get from coupon rates. So it's going to be $100 multiplied by this, so 0.04. So it's going to be $4. So in the first year, you're going to get $4. It's going to get discounted. This is going to be 1 because it's 10%. Plus, in the second year, you're going to get the same amount, but it's going to get discounted by 2 years, so it's going to be squared. And then in the final year, you're going to get paid the face value, and since the maturity is 2 years, it's going to be squared too. So this is going to be your price. And if you calculate this, you would have, let's see, $89.59. Next, instead of calculating the price, we will learn how to calculate the yield, reward, or the interest rate with the price known. So what we're trying to do here is trying to compare different bonds by their yields. So how do we do that? Before we get into the calculation part, let me introduce a key concept here, which is yield to maturity. So the yield to maturity is return, like the true value, the true yield of a bond that you own until maturity. So another definition here, written down here, is the yield of maturity is of any bond, it's an interest rate that equates to the present value of all future payments, which is fixed, to its current price, which varies. I know the definition here written down here is seems quite difficult to understand. So to simply put, the yield to maturity is the rate of return from a bond that you would get from owning that bond until maturity. So let's take a look at a simple case with the 1-year discount bond. It's simple because there's no coupon payments in between, and you get paid only face value at the end. The yield to maturity in this case would be FV minus P over P. FV is face value, which is a fixed value, and P is the price that you paid for the bond, or the price of the bond that was sold at that time. So FV minus P in the numerator would be the return that you would get from holding this bond until maturity. To get the rate of return, you would divide it with the price and multiply it by 100 to put it in percentage. So one thing you can note here is that the price is in an inverse relationship with the yield. So it means that when the price falls, then the interest rate increases, and if the interest rate falls, then the price increases. This will come up later in the lecture as well. Now let's take a look at a numerical example. What is the yield to maturity of a $100 face value of a 1-year discount bond selling for $94? So the return is going to be $100 minus $94. The rate of return is going to be dividing that by 94, multiply by 100, then I think this is 6.38%. So this means if you hold this bond until maturity, your yield is going to be 6.38%. Now let's say you buy the same bond but at a different price, at a different timeline maybe. So let's see what happens in this case. So the face value is same, $100, but you just buy it at $98. The yield to maturity in this case will be so this is 2/98, and I think this is a 2.4%. So let's try to compare these two cases. Let me get the answer from the previous one. So the one that you bought for $94, the yield to maturity was 6.38%. So I said this. This is what we see is if the price increased here, the yield to maturity decreased. So you can see the inverse relation. So this makes sense because yield to maturity is about return that you're getting, and if you're paying more for it, the reward you're getting eventually is less. Now let's take a look at a more complicated scenario where you're getting paid coupons. So what we need to know in this case is the face value, which is fixed, the coupon payments, or the coupon rate, this is also fixed, and we need to know the current price, the P, which varies. So let's look at an example for me to explain this. So what would be the yield to maturity for a 4-year bond that has a $1,000 face value and the coupon rate is 10%? And the price is $1,050. So how do we solve this for the yield to maturity? So remember when I defined the yield to maturity as the interest rate that equates to all the future payments and to its current price. Unlike the 1-year discount bond example, it would be very difficult to directly calculate the 4-year coupon bond yield to maturity because you get coupon payments in between. To solve this, we have to solve it in reverse. So using the price formula for coupon bond we learned earlier, we know the price is $1,050, that goes to the left-hand side, and this will equal to sum of all the present value of future payments you get. So what we don't know in this case is the I's. So the I's are the yield to maturity. So you want to solve this solve this equation for I's. Then you will know the yield to maturity for this 4-year coupon bond. So this is very complicated to do by hand. So normally you would use a computer or a calculator to do this. It would be more complicated if the maturity was longer. Let's say if we're trying to get the yield to maturity of a 30-year coupon bond, then the equation on the right-hand side will be longer. So you can also see here from the equation that the inverted relationship of I, or the YTM, is and the price is still there. So because I is in the denominator and price is here. So let's go over a simple numerical example where the right-hand side of the equation isn't that long. So it's a 1-year coupon bond with a face value of $100 with a selling price of $102. So let's set up the equation. We know the price, which is going to be $102 on the left-hand side, and this would equate to all the present value of future payments that we will get in the future. So the first payment we'll get is going to be the coupon payment, which is going to be 5% of $100. And that over interest rate. And since the 1-year coupon bond is going to be the power of 1. And then in the end, we will get the face value. So we want to solve this for I. So let's simplify the right-hand side. So this is going to be 105 over 1 plus I equals to 102. So if you solve this for I, so I think it's 1 plus I, 105 over 102. That's going to be 105. If you solve this, your yield to maturity is going to be 2.9%. As I said, this is a very simple example. Then let's look at a case where the maturity of a coupon bond is 10 years and the face value is $1,000 with the 10% coupon rate. So because it's so hard to calculate by hand, there is a table where it's actually all calculated for you. So one thing you can learn from this table is when the price of the bond is equal to the face value, then the yield to maturity is actually the same as the coupon rate. Another thing you can see is when the bond price is below the face value, then the yield to maturity is greater than the coupon rate. And when the price of the bond is greater than the face value, then the yield to maturity is less than the coupon rate. Let me summarize this in the next slide. Before I summarize it, let me introduce you. But before I do that, let me talk about another concept, the current yield. As you can see from the name, it's pretty straightforward. The current yield is simply the coupon payment divided by the price. It's simple, but you can't really say that the current yield reflects the return of a bond. So knowing this, we can say the following relationship is true for any type of coupon bond. So if the price is less than the face value, then the yield to maturity is greater than the current yield and the coupon rate. If the price is greater than the face value, then the yield to maturity is less than the current yield and less than the coupon rate. If the price is the same as the face value, then the yield to maturity is same with the current yield and the coupon rate. So the reason why this is important is because it's easier to find which bond has the higher yield to maturity. Let's say you're an investor and you want to buy a bond and you want to compare different bonds. You would definitely know the price of the bond that you're going to buy. You would know the face value, and you would know the coupon rate, but you want to know the yield to maturity. You don't have to go through all the difficult calculation. All you have to do is remember this relationship and see if the yield to maturity is greater than the coupon rate or less or equal to the coupon rate. So we have been talking about discount bonds and coupon bonds. So let me introduce you to a special bond called console bonds. So console bonds don't really have maturity dates, and they pay fixed coupons or interest rate forever. That means it has no face value because there is no maturity date. Then how will we know the value of a console bond because it pays forever? This is quite simple. the price of a console bond would be coupon payment divided by the interest rate. We can also rewrite this into interest rate equals coupon payment over the price of the console bond. So for example, a price of a console bond that gives you $5 coupon payment forever at 8% interest rate, it would be 5 over 0.08, which is going to be $62.50. So this amount, $62.50, is what we are going to pay for this console bond, and it will pay $5 forever. So even though console bonds and long-term bonds would pay you fixed payments, and so even though bonds like console bonds says it's going to pay you forever, and there are going to be long-term bonds that pay you coupons in between, it's really rare for investors to hold on to long-term bonds until it matures. So let's take a look at a different example. So the question is, what is the yield on a console bond with a 5% coupon and the selling price is $102? So for the question, it's asking for the yield, the I. What we know is the coupon payment is 5 and the price is $102. So remember in the previous slide we wrote the equation as I equals C over P. Doing that, we can find the yield of this console bond, which is 5 over 102, and this is 4.9%. So the yield of this console bond is 4.9%. So for long-term bonds like console bonds or just long-term bonds in general, it's really rare for investors to hold on to them until it matures. What happened is, let's say there is a 30-year bond, you can sell this bond after a couple of years you bought it instead of waiting for it to mature. So then how would we calculate the rate of return in this case? So we can't use the yield to maturity to calculate the return for buying a bond and selling it before it matures, because yield to maturity is calculated on the assumption that you hold on to the bond until it matures. So when you sell the bond before it matures, your return would be so when you sell the bond before maturity, your return would be most likely different from the yield to maturity you can calculate. Because now we assume that we sell a long-term bond at a very price before it matures, and you would get paid fixed payments only up till the point when you sell it, we have to take capital gain and capital loss into consideration. So how do we use that to get the rate of return of a bond? So let's start with the simplest case. We buy a bond, hold it only for a year, and decide to sell it. What would be the rate of return in this case? The capital R here stands for the rate of return. So this is where the current yield comes back in. The rate of return is the sum of the current yield, which represents the fixed payment part, and the rate of capital gain or loss comes from holding this bond for a year and reselling it after a year. So previously we learned that the current yield is coupon payment over initial price here. So we get the rate of capital gain or loss from change in price over initial price. So if the change in price is positive, you're getting a capital gain. If the change in price is negative, you have capital loss. So if the rate of capital loss exceeds the current yield, your rate of return will be negative. Keep in mind that the bond selling price will vary and is still in an inverse relationship with interest rate. So the reason why I'm saying this again is because let's say the interest rate increased. It sounds good, but remember that if the interest rate increased, it means the price decreased. When you're selling it, it means that you're going to sell it after a year when the prices decrease, which means that you're going to have capital loss. This is what we call the interest rate risk. So an interest rate risk is a risk that a price of a financial asset will fluctuate in response to change in market interest rate. So the size of the interest rate risk depends on the maturity of the bonds. Let's say if you have a 30-year let's say you have a 30-year bond and then you also have a 3-year bond, then the interest rate risk is going to be higher for the 30-year maturity bond because it's more likely to fluctuate in interest rate and the price will fluctuate as well. Let's go over a couple examples here. Suppose you're buying a 10-year treasury bond with 2.5 coupon rate. The face value of this treasury bond is $100, and the price that you bought it at that time is $108. So when you decide to sell it, the price of this bond decreases to $102 after a year. So then calculate the return for this bond. So what you do is the return of this bond would be $100 multiplied by the coupon rate over the price that you bought, plus since you sold it at $102 but you bought it at $108, there is going to be a capital loss of $6 over the initial price that you bought it. And when you do this, you would get negative 3.5 over 108, which is negative 0.032, which is negative 3.2%. So the rate of return for you holding this bond only for a year and selling it after a year is going to be negative 3.2%. Now let's look at a more complicated example. So in this question, it's asking you, when you buy a coupon bond that has a 6% coupon rate, and the face value is $100, this bond has 2 years left to maturity, but you're deciding to sell it after a year, which is you're selling it in 2020. And the interest rate here in 2020 is going to decrease to 1%. The question is first asking you about the price of the bond when you're selling it in 2020 and the rate of return when you decide to sell it. So let's try to think it this way. Let's draw it down in a timeline. So in 2019, you buy it. The price that you bought it was $100. And in 2020, you don't know the price. And you want to know the price. That's what the question is about. And in 2021, whenever this bond matures, someone who buys it will eventually get the face value payment, which is $100. And then in between these years, there's going to be a 6% coupon rate payment, which is $6. So this is a two-step question. First, you want to find out the price in 2020. And when you find out the price, you can calculate the rate of return here. So basically the price in 2020 means what is the present value of this bond, holding this bond in 2020. So if someone buys this bond from you, this person is going to get one coupon payment between 2020 and 2021, and that person is going to get the face value payment when this bond matures. So calculating the present value of this bond, holding this bond in 2020, would be $6 over 0.01 because 1% was the interest rate in 1% was the interest rate in 2020, plus the face value over 1.01. If you calculate this, you would get 104 $10.95. So when you're selling this bond in 2020, this means the price of this bond will be 104.95 cents. Since you bought this bond at $100, you would have capital gain. So the second part of the question is getting the rate of return, which is your current yield plus the capital gain part. So you get 4.95 for capital return, and this will be 10.95 over 100. So your rate of return would be 10.95%. So if you sell this bond after a year, you're actually are expected to get more. I'm saying this because if you hold this bond to maturity, what would be the yield to maturity? So we don't have to go through all the calculation. We know the face value here is $100, and the price that you bought was $100, which means the face value and the price was equal. So this means that the yield to maturity would equal to the coupon rate. We know the coupon rate was 6%. If you held this bond to maturity, your yield would be 6%, which is lower than the yield that you get if you sell this bond after a year. And now we know that most bond payments pay you fixed payments throughout the life of a bond. You're getting paid coupon and face value when you buy a bond. So this is very good in terms of stability. So you're getting fixed payments until it matures or until you sell it. But the value of these payments can be eroded by inflation. So let's say, for example, you buy a 30-year bond and you get paid $5 coupon every year. So the $5 payment that you get at the beginning, like at year one, would not be the same. The value of it would not be the same as the $5 payment that you get at year 30 because of inflation. This is why investors care about real interest rate, or we call it inflation-adjusted inflation rate instead of nominal interest rate. So the I we were talking about earlier when we were calculating the present value, the I we were talking about is the nominal interest rate. So then how do we get the real interest rate? So the real interest rate is nominal interest rate minus the inflation, expected inflation. So the R here stands for real interest rate. I is the nominal interest rate that we were talking about, and then pi here stands for inflation rate. The reason why there's a superscript E is because it's expected. We were talking about expected inflation. So when you're calculating the real interest rate, no one really knows the true inflation rate at that time. So the real interest rate requires investors to make predictions about the future inflation rate. So because of this, what happens is actual inflation rate can be really different from what you expected. It might be the same sometimes, but most times it'll be different. So therefore, investors may receive different real interest rate from what they actually expected. Let's go over an example here. Let's say that in 2019, you lend $100 to a friend who promises to repay you in 2020 $120. So your interest rate here is going to be 20%. Well, the interest rate here we're talking about is nominal interest rate. You expect there's going to be a 5% inflation rate, so that's your expected inflation rate. But when your friend actually repays you in 2020, the inflation was actually 10% in that year. So given this information, your expected real interest rate was your expected real interest rate was going to be the nominal interest rate minus the expected inflation rate, which is 15%. But when it turns out the actual inflation was 10%, the actual real interest rate turns out to be 20% minus 10%, which is 10%. So what you can see here is you expected your real interest rate to be 15%, but it turns out it's 10%. So in a case where the inflation turns out to be smaller than you expected, then the lender, yourself in this case, would be hurt, and then the borrower, your friend in this case, would actually gain from this situation. So let's summarize that. When your inflation rate is higher than you anticipated, then the borrowers benefit and the lenders are hurt. And then vice versa, when the inflation rate turns out to be lower than you expected, then the lenders benefit from this, and then the borrowers get hurt. So this is the end of this unit, and I will see you in the next unit.